Okay, so you put to estimating the population proportion. Let's go ahead and finish this up. We're going to do the second part. Second part starts on page 517 where it says putting it all together, the four-step process. Okay, if you look at on the right underneath there, there's a green box. SPDC. Okay, SPDC. These are the four steps. Whenever somebody asks you to construct a confidence interval, this is what you're going to do. As a matter of fact, you are going to write state. Okay, you're going to write state, and then you're going to say, okay, this is what we're doing. Okay, I am constructing a confidence interval for proportion with a certain confidence level. Okay, then I'm going to plan, and planning means I am checking the prerequisites. Okay, what were they? Simple random sample, right? It has to be a random sample. Then n has to be less than 0.1 big N, and then large counts, right? So these three things. So these three things will be in the plan stage, and you will write them down so that I know that you've checked on each one of these. Okay. Do is actually doing the math. So I'm going to go ahead and do the p hat z star square root of p hat 1 minus p hat over n. I'm going to do this. This is the do. C is the conclude. Conclude is where you are going to interpret the confidence interval. This is where you're going to say, we are 90% confident that the interval that I found here, specifically state that what that was, contains or that captures the true proportion of whatever the question was. Okay, so in your answer, you will have these four words: state, plan, do, and conclude. Okay, these are the four words that your AP Stat test graders will look for also. Okay? Again, state, plan, do, and conclude. Okay? And then you just follow, you can just cookbook it after that. Okay? All right, so there we go. All right, so let's see if we can do this. Let's see if we can do example on page 517. Distracted walking. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. Construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. Okay, so classic state, plan, do, conclude, right? Our state. So what are we going to do? We're going to do a confidence interval for the proportion of people or cell phone users who are distracted and walk into someone or something while talking on their cell phone using a 95% confidence level. Okay? That's our statement. Okay. Plan. Let's check to make sure we have everything here. It was a random sample, so we're good to go. Okay? And it was 738, and we know that that is less than 10% of all of the cell phone users, right? Okay. And then we have to find that, what, NP, N was 738 times, and how many were, 107 were distracted, was it? How many were distracted? 170, not 107. 170 times 7 over 738, and I know this is greater than or equal to 10. And I also know that 171 minus P, which would be 738 minus 170, 68 over 738, that would be 568. So that is also greater than 10. So the large counts is satisfied too. You have to write these down, okay, in your answer. These have to be very evident that you check these. Do. So let's do this. So it's going to be what? 170 over 738. That was the p hat. Plus or minus. What is our z star for 95%? What's our z star?
$1.96.
1.96, right? Square root of 170 over 738, 1 minus 170 over 738, divided by n. What was the n? N was 738, right? And if I do all that, I'm going to come up with a confidence interval of 0.00, 0.0200 to 0.260. Okay, so Kayla, conclude for us.
We are 95% confident that from the interval 0.200 to 0.260 captures the true proportion of all the cell phone users that admit to walking into something.
Nice, very good. Okay, that is very important. Okay, we are 95% confident that 0.200 to 0.260 captures the true proportion of cell phone users who are distracted and walk into something or walk into people. Okay, all right. Again, it's kind of cookbooky, but this is the way to do it. Okay, obviously, your calculator knows how to do this too. So if you look at the bottom part of 518, there's a technology corner. I want you guys to bring your calculators out and we'll go over this together. So in the technology corner, okay, what you're gonna do is you're gonna go stat tests. And this is a one prop z test. Okay, one proportion z test. So one proportion. So we're gonna learn about the two proportions later on. So one prop z test. So one prop z test, go there, and that's gonna give you X and N. X is the number of people that you found that were distracted, N is your sample size. Okay? And then you're gonna put in your confidence level, which is 95%, and hit calculate, and it should give you this number right off the bat. 0.200, 0.260. Were you able to find that? And it's also going to calculate the p hat for you, which is nothing more than 170 divided by 738. Are we good? Give me a thumbs up if you were able to do this on your calculator so that I know that you were successful. Okay, most of you are, I see a thumbs up. Okay, Eva, you good?
Mine looks different, but I think I can figure it out.
Okay, all right. Braden, you were good? Okay, we're good. Okay, all right, all right. All right, well, good. Okay, sounds good. It's good. All right, so let's move on from that. Let's go to choosing the sample size. Okay, choosing the sample size. So when we talked about choosing the sample size, one of the things that we said that the larger the sample was, the smaller the margin of error was going to be, right? Because what actually is the margin of error here? The margin of error is everything over here. This is the margin of error, correct? Because it is the p hat plus or minus the margin of error, right? So we're talking about how do we control this size, okay? We obviously want the margin of error to be small. For the margin of error to be small, we have to do what? We have to have a low confidence level. We talked about this, right? And we also have to have a large n, right? And those are two things we talked about, yes, last time we met, okay? So if I go to a polling or the Gallup poll or Pew Research Center and say, I want to do a survey for this and this and this, and the very first question they're going to ask us is, what do you want the margin of error to be, right? Because if you do a survey and the margin of error is plus or minus 20%, it's really a meaningless thing, right? Who cares if it's going to be that big, right? You want the margin of error to be small, right? So they're going to ask, well, what margin of error do you want to be? And depending on that, you're going to control either this guy or you're going to control this guy, right? Because you cannot control p hat. P hat is what it is, right? Really, you have no control over that, right? You can control this. You can control the confidence level, right? By controlling the Z star. You can also control the sample size, okay? The problem with the sample size is that, yes, the larger the sample size you have, the smaller margin of error you have, but you are also limited in money, right? You can't just go big, a huge N, right? Because you have to pay to get that survey size, right? Okay, so that's what you're going to do. Okay, one thing that you need to know here is read that green box on the bottom of page 519. At the very end, there is a blurb there that you should pay close attention to. And it says, where p hat is a guessed value for sample proportion, the margin of error will always be less than or equal to that if you use 0.5. So if you do not know, what p hat is, you're going to use 0.5. Okay? Most of the time, you will know what p hat is. Okay? Flip the page. And there's an example of customer satisfaction. I'm not going to go over this. You can go over, you can read it through. It's really not that involved. Okay, it's just plugging and chugging and figuring out the margin of error. Okay, so I'm not going to go through that. You guys can read that. And we are done with 8.2. We are done with 8.2.